Hi and Assalamualaikum. In today's video, our group will be present about one of application of differentiation, which is apply maximum and minimum. So let me introduce our amazing group members, which is Siti Khadijah binti Muhammad Shukri, Nurul Munira binti Abdullah, Nur Farha Nabila binti Zaharuddin, and last but not least, Nur Atika Nadira binti Muhammad Samsuzli. We are really grateful to our respectable lecturer, Madam Shazwani, who has been instrumental in guiding us through this project successfully. With her wisdom and knowledge, we were able to complete this report with ease under her supervision, which was a very enriching experience for all of us. We also would like to thank Madam Shazwani, whose advice and make the production process much smoother and easier than expected, considering it was such an ambitious task from the start. Lastly, with our group members covered along the way, I'm not sure if we could have made it here today, so thanks go out as well to everyone else that contributed at some points or another during our journey on completing this remarkable undertaking together.
So, for the first one, what is differentiation? Differentiation is a process of finding derivative or rate of change of a function. Why? Because to determine the maximum and minimum values of a particular function. So, the rate of function is defined as dy over dx equals to fx equals to y. There's three techniques to solve differentiation problems. The first one is derivative of sum and difference. The second one is derivative of product functions, the product rule. And the third one is derivative of rational function, the quotient rule.
Application of differentiation. There are 5 applications of differentiation. The first one is rule theorem and mean value theorem. The second one is analysis function 2, which is relative extrema, first and second derivative test. The next one is maximum and minimum problem. The fourth one is analysis of function 1 that include increasing, decreasing, and concavity. The last one is related rate.
Apply maximum and minimum problem. First, the process of finding maximum and minimum value is called optimization. Second, for example, maximize the profit in a company, minimize the cost, and find the least amount of material to make a particular object. Third, technique is appropriate to use in determining a maximum and minimum value. The extremum value theorem, the first derivative and the second derivative.
There are 3 objectives that have in application of differentiation, which is to express h in terms of r, and the second one is to show that the area A equals to 11 over 3 pi r square plus 8064 over r, and the last one is to find the minimum area. Situation. One day, Sumaya gets killed from her school because she got straight A for her final year exam. She get cute dustbin that looks like a robot, like the figure shown. After a second, she just realized that the dustbin looks like cylinder and a hemisphere. Coincidentally, she just learned about apply maximum and minimum of differentiation.
Problem statement. Figure shows a hemisphere with radius r, centimeter, and head hash centimeter is placed on cylinder. Given that radius of hemisphere and cylinder is same.
Problem solutions. 1. If the volume of the hemisphere and cylinder are 432 pi cm cube, express H in terms of R. So the solution is step 1. V equal to 432 is the volume of cylinder and hemisphere. Step 2. V equal to 2 pi r cube over 3 plus pi r square h. Step 3. 2 pi r cube over 3 plus pi r square h equal to 432. Step 4. Pi r square times with 2r over 3 plus h equal to 4032. Step 5. 2 over 3r plus h equal to 4032 over pi r square. Step 6. H equal to 4032 over pi r square minus 2 over 3r.
The second problem solutions shows that the area of hemisphere and cylinder given by A equals to 11 pi r square over 3 plus 8064 over r. So the solution goes like A equals to 2 pi r square plus 2 pi r hash plus 3 pi r square equals to 2 pi r square plus 2 pi r multiply with 4032 over pi r minus 2r over 3 plus 3 pi r square equals to 2 pi r square multiplies with 8054 pi r over pi r square minus 4 pi r square over 3 plus 3 pi r square equals to 5 pi r square plus 8064 over r minus 4 pi r square over 3 equals to 11 pi r square over 3 plus 8064 r. So it is sure, right?
3. When r equal to 12, find the minimum area of hemisphere and cylinder. A equal to 11 pi r square over 3 plus 8064 over r. dA over dr equal to 22 pi r over 3 plus 8064 r to the power of negative 1 equal to 22 pi r over 3 minus 8064 r to the power of negative 2 equal to 22 pi r over 3 minus 8064 over r square. That is d square a over dr square equal to 22 pi r over 3 minus 8064 r to the power of negative 2 equal to 22 pi over 3 plus 60,128 r to the power of negative 3 equal to 22 pi over 3 plus 16,128 over r cube. When r equal to 12, d square a over dr square is equal to 22 pi over 3 plus 16,128 over 12 cube equal to 16.67 pi cm square. Conclusion. By applying differentiation method into this problem, we can conclude that the application of differentiation can be used to define a value of volume, solve any other kind of problem, and solve problem related to value of volume.